Okay, so method 2 is backtracking. So backtracking is actually getting you to think about what's happening with the equation and working backwards. So this means that BODMAS, and I know a lot of you go, what the hell? Why do I have to use this all the time? Because guess what? You have to use it all the time, which means brackets, order of, division and multiplication, reading left and right, addition and subtraction. You must do it in that order. So this backtracking actually requires you to write out what is happening to the unknown, and the unknown is, you know, the pronumeral x, y, z, or whatever it is, and then you have to work backwards. Unknown and work backwards. Right, so my first equation, if you have a look at it when I write it up, is like this. I have this equation, x plus 4, all of that is divided by 5 and it equals 3. So like I was just saying, what am I doing to x? Well, in this case I'm going x plus 4, so what I'm doing to that plus 4 is a certain number, and then I'm dividing whatever that number is by 5, and my answer is 3. So for me to work backwards, it starts off with 3. I have to do the opposite. So the opposite to adding is taking, and the opposite to dividing is multiplying, and vice versa. So the opposite to dividing is times by 5. 3 times 5 is 15. Now this is plus 4, so the opposite to plus 4 is take 4. So 15 take 4 is 11. So I'll just check that. So I'll say, okay, therefore I think x equals 11. So I'll recheck it. I'm going to go 11 plus 4 is 15 divided by 5 equals 3. Oh, look at that, it works. So x must equal 11. But again, this takes a long time because you can see I had to draw the boxes and I had to think about opposite values. What's the opposite to this and things like that. So it takes a long time too. So this again is not actually what we use all the time. This is our method 3, which is called inverse operations. Inverse just means the opposite. So this is exactly the same as backtracking basically, but without the boxes. So I'll write down the opposite first. I'll just remind you what opposite means. The opposite means inverse operations. So plus is opposite to take and times is opposite to divide and vice versa. You really need to understand that. So if you have a look at this problem here, you will see that I have x plus 3 equals 1, 2, 3, 4, 5, 6, 7. So I'm sure you can do that in your head because it's a simple sum. But as you know, that guess and check can take a long time if we're doing something else. So we'll just have a look at this. That's our sum. So I'll write it up here again. X plus 3 equals 7. So you'll see that I've got a DC's law of the universe. Whatever you do to one side, you must do to the other. That is DC's law of the universe. You must do to the other. So you'll see, I'm not even going to look at the answer. I'm not interested in it. So just give me a sec and I will see what I can do. So I am not even going to look at the answer, so I'm going to move this over that. So I'm looking at this and I say to myself, x plus 3. I want to get x by itself. So how do I do that? I have to get rid of the 3. So I've got x plus 3. What's the opposite to adding 3? Oh, that would be take 3. So whatever I do to one side, I must do to the other. So you see that? If you just look at this side, can you see that if I have $3 and I took $3 away, I'm going to end up cancelling them out? I've got nothing left there. So on this side of the sum, I only have x. On the other side of the sum, however, I think I've drawn, just give me a sec. On the other side of the sum, you'll see that I've got 7 take 3. 7 take 3, which is 4. Wow, if you did that in your head, you would see 4 plus 3 equals 7. Wow, that works. So I'm going to underline it. But things aren't usually that simple. We usually have problems that are a bit harder. So what about this one? 2x, notice that my x's like 2 c's back to front or backing up on each other, equals plus 3 equals 17. So you'll see 2x plus 3 equals 17. Again, I am not going to look at this. So I will cover it, one hopes. Move if you can, there we go, I'll cover it, there we go. So we know there's 17 under there, but we don't have to look at it at the moment. So if I look at this sum, you will see that it's really 2 times x plus 3. So this is what I do. Can you see what I said? I went and said what the sum is doing. So the last thing I said was plus 3, so the first thing I have to do is the opposite to that, which means I take 3. Whatever I do to one side, I must do to the other. So in this case, it equals 17. See, I didn't even care what the 17 was, did I? So on this side, you'll see that I've lined them up as well. That cancels out, and I'm left with 2x on that side. 17 take 3 is 14. Okay, so here I've got times on this side again, so I'm on to the next line. 2 times x. What's the opposite to times? Divide by 2. So opposite to times is divide. Law of the universe says whatever I do to one side, I must do the other. So 2 divided by 2 leaves 1, which means that that is x, because 1x really, but we never write that in. So it's just 1x equals, what's 14 divided by 2? 7. All right, so now what I need to do is check my sum again. 2 times 7 plus 3 equals, let's see, 2 times 7 is 14, 14 plus 3 is 17. Oh wow, that's what we had, so that must be the answer. Therefore, x equals 7. There we go.